Hi everyone, welcome back to my channel Mathematic Girl Swati 3226. So yes, this is the third part of the video, and in this third part, I'm going to finish this exercise 7.2 integration question that is from NCERT. So in this particular video, I'm going to cover the third part, as I said, where I'm going to cover the questions from 28 to 39. We have total 39 questions, and yes, I have made basically three parts of this particular exercise, that is 7.2. So in three parts I have covered all the questions. There are 39 questions. The first part I have covered few questions 1 to 10. In the second part I have covered almost 11 to 27, as you can see here. And this particular video is the third part of the video where I'm going to cover the questions from 28 to 39. Okay, so I'm going to put the link in the description box for the first part and the second part. So please watch those videos if you have not watched those videos till now. And then you can watch this video. And if someone is watching this video, after watching the other two videos, then you are at the right place. You can absolutely continue watching this particular video. So let's start without any further delay. 28th question. So in the 28th question, we have to integrate cos x upon root over 1 plus sin x dx. So this is the question. Now we have to integrate this. So what I'm going to substitute here, I'm going to put 1 plus sin x as t. So if I do the derivative of 1 is 0 and derivative of sin x is cos x dx equals dt. So therefore, I'm writing it here, okay? When you are writing in the examination, in your exam, please write down here, okay? Just like sequence wise. I'm just trying to make some extra space. So that is why I'm writing it here. So integration, this is cos x dx. So for this cos x dx, we have the term dt. So I'm going to replace it with dt. And then upon root over 1 plus sin x is t. So it is t. Now this is nothing but dt upon root t we can write down as t raised to half. And this we can write down as by using property of exponent. So that will become t raised to minus half dt. Now integration of this is very simple. T raised to minus half plus 1 upon minus half plus 1. By which formula? By this formula, that integration of x raised to n dx is x raised to n plus 1 upon n plus 1 plus the constant of integration. Make sure when you are solving questions, you are writing the formula on the side. So therefore, this will simply become t raised to minus half plus 1. If you take LCM, it will become half. And this will also become half only. So this will become 2. T raised to half is nothing but root t. And 2 root t is nothing but your 1 plus sin x. And that is your answer. And we are done with the 28th question. Let's go to the 29th question. Okay, don't forget to put the constant of integration. So it's plus c, and then it's plus c. Okay. All right, so let's go to the 29th question. So in 29th question, you have to integrate cot x log sin x dx. So you have to integrate here cot x log sin x dx. Now here, what are we going to do? We are going to put log x equals t. So let's start with the solution. So if I put log x, log sin x, not log x, log sin x equals t, then simply by using by doing the derivative and by using the formula, derivative of log x is 1 upon x. So this will become 1 upon x, that is sin x. Here at the place of x, we have sin x, so it is 1 upon x. And then by the chain rule, if you do the derivative of sin x, it is cos x. So cos x, and then of course dx equals dt. Now you know by formula that cos x upon sin x is nothing but cot x. So I can write down here cot x dx equals dt. Therefore, I can write down my integration as integration of, for this cot x dx, I have dt. So I can rewrite this as dt. And then log sin x is nothing but t. Oh, this is so simple now, t. So what is integration of t? It is so simple. T raised to 1, so 1 plus 1 because it is n plus 1. and then upon 1 plus 1 same plus the constant of integration. So this will become t square upon 2 plus c. T is nothing but your log sine x. So log sine x whole square upon 2 plus c. This is your answer. Let's go to the next question now. That is the 30th question. So in 30th question, you have to integrate sine x upon 1 plus cos x dx. All right. Okay, so let's simplify this. So here, of course, I'm going to put 1 plus cos x as t. So if I substitute here 1 plus, let's put 1 plus cos x equals t. So derivative of 1 is of course 0 and derivative of cos x is minus sin x. It is minus sin x dx equals dt. Now I'm going to put here like keep sin x dx as it is and this will become minus dt. So therefore my integration will now become for this sin x dx I have minus dt. So I can write down this as minus sign here, dt here, and then upon 1 plus cos x is t, so it is t. Now this will become minus integration of 1 upon t. You know the formula, it is log mod t plus the constant of integration. So here I'm writing the formula every time, not writing the formula, but at least I'm saying the formula every time. Make sure when you are doing all these questions, you are writing the formula every time. So integration of 1 upon x dx is nothing but log mod x plus c. So this will become minus log mod t is 1 plus cos x, so it is 1 plus cos x and then plus c. So this is the answer. Now let's go to the 31st question. We are almost going fast, but we have some complicated questions almost like in 37th or 38th question. So hang on. Okay, so let's do 31st question. Integrate sin x upon 1 plus cos x whole square dx. This is again almost similar to the previous one. So I'm going to substitute here again 1 plus cos x t. So let us put 1 plus cos x equals t. So if you do the derivative, it is 0. Cos x derivative is minus sin x dx equals dt. So therefore, sin x dx will be nothing but minus dt. Therefore, we can write down this as integration. For sin x dx, we have minus dt. So it will become minus here, dt here. Upon 1 plus cos x, we have taken as t. So t square. But this is very simple. Minus outside. Integration 1 upon t square by using the property of exponent. This will become t raised to minus 2 dt. Now, if you use the formula, it will become minus. Integration of this is going to be x raised to n is x raised to n plus 1. So here n is minus 2. So n plus 1 upon n plus 1. And then of course plus constant of integration. So it will become minus t raised to minus 2 plus 1, that is minus 1. And this is minus 2 plus 1, that is again minus 1. And then plus c. Now here we have minus, here we have minus. So minus minus is plus. So it is t raised to minus 1, which is 1 upon t by using the property of exponent. Therefore, the answer is 1 upon t is 1 plus cos x. So 1 upon 1 plus cos x plus c. That's your answer. Let's go to the 32nd question now. And yes. So in the 32nd question, we have to integrate 1 upon 1 plus cot x. Now, all these questions are, almost similar. It's just little bit, like I can say tricky by just writing the terms in cortex. Otherwise, it is very, very simple. Okay, so let's do this. So whenever, like I personally suggest you that whenever you see any other trigonometric function other than sine and cos, try to convert it into sine and cos. So this is what I'm going to do here, 1 upon 1 plus cot x. We know that by formula. Cot x is nothing but cos x upon sin x, right? So using this, it will become cos x upon sin x dx. Now, if you simplify this, if you take LCM, this will become 1 upon 1 plus, this will become sin x because we have taken LCM. Sin x plus cos x upon sin x and then dx. And now this will become integration. This sin x that is in the denominator here, that will become that will come here. That is sin x in the numerator now, and then sin x plus cos x dx. Now here we need to simplify this further by multiplying the numerator and denominator by 2. So if I do that, it will become this 2 sin x, and then here also 2 times sin x plus cos x. Now I can write down this as this 2 sin x as sin x plus sin x. Yes, of course you can write down. And this is 2 sin x plus cos x as it is. And then dx, of course. Now in the numerator, I'm again going to do something. So sin x and this plus sin x as it is. Here I'm going to do plus cos x and minus cos x. Remember, it is plus minus, so no effect to your question. And then in the denominator, we have this 2 sin x plus cos x as it is. And then, of course, dx. Now, if you separate the LCM, it will become the sin x plus cos x as it is. And then upon, if you want, you can keep this 2 outside. That would be better. So 1 upon 2 outside, and then do everything like this. So sin x plus cos x, the LCM we have separated. And then on that side, we have plus sin x minus cos x. And then this is sin x plus cos x. And then, of course, dx we have here. Let me close the bracket. Now, simply the sin x plus cos x is nothing but 1. So this will become 1 upon 2, and then integration of 1. If you want, you can distribute the integration. So 1 dx plus integration of, this is sin x minus cos x upon sin x plus cos x dx. Now this looks very complicated, but trust me, it is very simple, because solving this particular part is very simple if you do the substitution. So for this, I'm going to do some calculation here by putting sin x plus cos x as t. So if I put sin x plus cos x as t, it will, like if I do the derivative, sin x derivative is cos x, and cos x, sin x derivative is minus cos x, and cos x derivative is sin x. And then, of course, we have dx equals dt. Correct. So now what are we getting? We are getting cos x minus, second. Okay, so derivative of sin x is cos x, and derivative of cos x is minus sin x. Correct. This will become cos x minus sin x dx equals dt. Now here what I'm going to do, I am going to take minus sign common. So if I take minus sign common, it will become sin x minus cos x dx equals dt. So from this, I can also write down that sin x minus cos x dx equals minus dt, right? So now let us simplify this integration. So this is 1 upon 2. Integration of 1 dx is nothing but x. So half x plus this half will also get multiplied with this. So half integration sin x minus cos x dx. For this particular expression, we have the value minus dt. So this will become minus dt upon sin x plus cos x we have taken as t. So it is t. Very simple. This is x upon 2. This minus will come outside. So it is 1 upon 2. This is 1 upon t dt integration. So this will become log mod t plus c, the constant of integration. So we have taken t as sin x plus cos x. So simply we are going to put the value of t, and that will become log mod t is sin x plus cos x, and then plus c. And this is the answer. So we have the answer x upon 2 minus half log mod sin x plus cos x plus c. Now let's go to the 33rd question, 33th question. Okay, 33. Let's go to the 33 question. I can say 33rd. Okay, so in 33 question question number 33, we have to integrate 1 upon 1 minus tan x dx. Again, you can't see here sin x and cos x. The best thing that you can do here is to convert this in terms of sin x and cos x. 1 upon 1 minus, we know that tan x is sin x upon cos x. So this will become sin x upon cos x dx. Now, if I take LCM here, this will become that cos x that you can see here, that will go in the numerator, right? And after simplifying this, and this is cos x minus sin x. So I've skipped one step here. So now we have integration of cos x upon cos x minus sin x. Now I'm going to simplify this further by multiplying this by 2 and this also by 2. So now I can write down this as 2 cos x as cos x plus sin x. Sorry, cos x plus cos x, because 2 cos x is cos x plus cos x only. And then here we have as it is 2 cos x minus sin x dx. And now I can write down this as integration. This cos x I'm writing as it is, and other cos x also I'm writing as it is. Here I'm going to subtract sin x and add sin x. This is what I'm going to do. And then upon, we have this 1 upon 2 outside, and then cos x minus sin x as it is, and dx. So this will become half. If you separate the LCM, this will become cos x minus sin x upon cos x minus sin x, which is ultimately going to be 1 only. But still I'm writing this. And then for this, we have cos x plus sin x upon cos x. This is similar to the previous question. Exactly same as this. It's just we have in the numerator, we got 2 cos x. All right. I can write down the bracket here and then dx. So we can write down this as 1 upon 2. Let's separate the integration. So integration, this is nothing but 1 dx plus 1 upon 2 integration of cos x plus sin x upon cos x minus sin x dx. Now here I'm going to do something very quickly. I'm going to simplify this, the second term over here by putting cos x minus sin x to be t. Go a little below. All right. So I'm going to substitute, as I said, if I put for the second term, right? If I put cos x minus sin x as t, the derivative of cos x is sin x, and derivative of sin x is minus cos x. Derivative of cos x is minus sin x. I'm extremely sorry. And derivative of minus as it is sin x is cos x. Oh, yeah. I know that this is little bit confusing, because even when I used to, do the derivative question, because it is just the opposite in the integration. So it's like I used to get confused. But yes, derivative of cos x is minus sin x, and derivative of sin x is cos x. So if I take here minus sign common, it is simply sin x plus cos x dx equals dt. So therefore, this will become sin x plus cos x dx equals minus dt. So therefore, this will become 1 upon 2. Integration of 1 is nothing but x plus half as it is. Integration of this cos x plus sin x dx. This cos x plus sin x dx is nothing but minus dt. So at the place of that, it will become minus dt. And then cos x minus sin x is t. So this is t. And I can write down this as x by 2 minus sign outside 1 upon 2. Integration of 1 upon t is log mod t plus the constant of integration. So simply it is going to be x upon 2 minus 1 upon 2 log mod t we have taken as cos x minus sin x. So cos x minus sin x and then plus c. That's our answer. So we are done with the question number 33. Now let's move to the question number 34. So I'll quickly take you to the left side where we were initially, and let's write down the 34th question. So in the 34th question, you have to integrate root tan x upon sin x cos x. Sin x cos x dx. So I will go down. Yes, okay. So in this particular question, you have to integrate root over tan x upon sin x cos x. So here again, we are going to simplify our question first by adding something, okay, or I can say by multiplying something. So here I'm going to multiply the numerator as well as denominator by cos x. So this is root tan x, and then you multiply this by cos x, and even if you multiply this by cos x, so cos x into cos x will become cos square x, right? And then of course this is dx. Now this will become integration. This is root tan x as it is. I'm writing this sin x as it is. I'm writing this cos square x as 1 upon cos square x separately. And if you can notice, I can shift this cos x over here. It is same as this, okay? Because if this cos x is present over here, in the next step, it will go to the numerator, right? So I've just, reversed back. Like I have gone reversed. So yeah. And now this will become integration root tan x as it is in the, okay, tan x. So this is sin x upon cos x. We know that sin x upon cos x is tan x. So I can write down tan x. And then we know that 1 upon cos x is sec x. So 1 upon cos square x is sec square x. So this is sec square x dx. So I'm just going to write down here. So I can write down this as integration root over tan x times sec square x dx. I can write down this tan x as root over tan x whole square. We know that root and square will get cancelled. So it is just tan x, right? But I'm just going to simplify this. Now this square root and this square will get cancelled, right? So therefore, what I'm getting sec square x upon root over tan x dx. This is the simplified form. Okay, now we are going to solve this integration by putting tan x equals t. We know that derivative of tan x is sec square x, and then dx, of course, and then dt. So therefore, our integration will now look like integration. For this particular sec square x dx, we have dt. So therefore, this will become dt, and then upon this will become root t. So now simplifying this is very, very simple. So simply this will become integration t raised to minus half by using the property of exponent. And this will become t raised to minus half plus 1 upon minus half plus 1 plus the constant of integration, that is actually t raised to half only, and then upon half, and then plus the constant of integration. This is nothing but 2. This is root t and then plus c. T we have taken as tan x. So t 2 root tan x plus c. That is your answer. And we are done with the 34th question as well. Now let's move to the 35th question quickly. Okay, so in the 35th question, we have 39 questions only, okay? And out of which 38th and 39th questions are MCQs. So let's solve this quickly. Integration 1 plus log x whole square upon x dx. Now this is very simple. You simply put 1 plus log x as t. So let's simplify this. So if you put 1 plus log x as t. So if you do the derivative, 1 is 0, derivative of log x is 1 upon x, dx equals dt. So now for this particular 1 upon x, dx is dt. So I can write down the question as integration 1 plus log x is nothing but t square. And then this 1 upon x dx is the dt. Now by using the formula, this is very simple. T cube upon 3 plus c. T is nothing but 1 plus log x. It is 1 plus log x whole cube upon 3 plus c. I think this was super simple question, the 35th question. Now let's move to the 36th question quickly. So in the 36th question, you have to integrate x plus 1 times x plus log x whole square upon x dx. This is what we need to simplify. So what I'm going to do here, I'm going to rewrite the question as x plus 1 upon x and then times this x plus log x whole square as it is and then dx. Now here I am just going to separate the LCM. So this will simply become integration x upon x is 1 plus 1 upon x, right? And then this is x plus log x whole square dx as it is. Now here I am going to substitute x plus log x as t. Now if I do the derivative, x is 1, derivative of log x is 1 upon x, and then of course we have dx equals dt. Now you can see that why I did all these things, because I am getting now 1 plus 1 upon x dx. The value of this is dt. So therefore, I can write down my question as integration for this yellow thing. 1 plus 1 upon x dx is nothing but dt, so it is dt. And then x plus log x I have taken as t only, so it is t square. And if I do the derivative, it is t cube upon 3 plus c. T is nothing but x plus log x, it is x plus log x raised to 3 upon 3 plus c. That's the answer. Now let's go to the 37th question. All right. So in the 37th question, you have to integrate x cube sine of tan inverse x raised to 4 upon whole upon 1 plus x raised to 1 plus x raised to 4. Yeah, we have 1 plus x raised to 4 dx. Okay, so this is the question, and now we need to simplify this. So here, what are you going to substitute? You are simply going to substitute here x raised to 4 as t. So if I put here x raised to 4 as t, this will simply become 4x cubed dx equals dt by using the formula of derivative. And this will become x cubed dx is equal to dt upon 4, right? So therefore, I can write down the question as integration for this x cubed dx. I have dt upon 4. So I can write down dt here and that upon 4 outside. And then sine as it is, then tan inverse x raised to 4 I have taken as t, so t, and then 1 plus x raised to 4 I have taken as, 1 second, yeah, x raised to 4 I have taken as t, so it is 1 upon 1 plus t. Okay, so this is not x raised to 4, this is x raised to 8. Otherwise, it is impossible to solve this question. So this is x raised to 8. So I can write down this x raised to 8 as x raised to 4 raised to 2 by using the property of exponent. But x raised to 4 is t, so it is t. And then we have a square, so t square. I hope it is clear. Okay, so now after this particular question is like, a substitution of substitution. So we are again going to substitute here. This time I'm going to substitute tan inverse t as m. So what is the derivative of tan inverse t? We all know that it is 1 upon 1 plus t square dt equals dm. Okay, derivative of f, that is dm. Therefore, I can write down the question as 1 upon 4 as it is, sine as it is, tan inverse t I have taken as m, so it is sine m. And for this 1 plus t, oh, I'm extremely sorry. I need to erase this. I hope I'll be able to erase it. Yeah. Okay, I can erase this completely. I can write down once again. Yeah, so 1 plus t square, all right? So I can write down this as 1 upon 4 sine m. And for this 1 plus t square dt, see, we have dm. So I'm going to write down here dm. It's that simple. So it is like maybe you are looking at m, so you are getting confused, but it is same as integration of sin x dx, right? So if you know what is integration of sin x dx, you can simply find out integration of sin m dm as well. So integration of sin x is minus cos x, so this will become 1 upon 4, and this will become minus cos m, right, plus c. So it is nothing but minus cos m. M is nothing but tan inverse t from here. So this will become cos of tan inverse t, and then of course upon 4 plus c. But this is not the end. We have to put the value of t as well. So this will become minus cos tan inverse t we have taken as x raised to 4, as you can see here, which is, I'm writing over here, tan inverse x raised to 4 upon 4 plus c, and this is your final answer. So if you want, you can also write down as minus 1 upon 4 cos tan inverse x raised to 4 plus c. Okay, so we are done with the 38th question. Now, sorry, 36th, 37th question. Now it's time to go to the 38th question. So 38th question is basically a multiple choice question. So I'm just going to write down the question. If you are having your NCERT book, you can see all the options. I'm just going to write down the question. I'm going to simplify it, and I'm going to tell you the answer. Okay. So 10x raised to 9 plus 10 raised to x log base e 10 dx upon x raised to 10 plus 10 raised to x. So we need to simplify this. Okay, I have already written dx here, but I'm just writing it over here now. So yeah. So we need to simplify this. Again, this looks complicated, but this is very simple. All you need is to substitute the denominator as t. So x raised to 10 plus 10 raised to x equals t. Now x raised to 10, it's very simple. 10 x raised to 9, right? Because the derivative of x raised to n is n into x raised to n minus 1. Now derivative of a raised to x, right? Because we have 10 raised to x, it is same as a raised to x. So derivative of a raised to x is a raised to x as it is, and then log a. So using this formula, this will become plus a raised to x, that means 10 raised to x as it is, and then log, here base is e, so log base e, and then the value of a is nothing but 10, so it is 10. And of course, dx equals dt. Now you can see here that we have exactly this expression over here, and that is equal to dt. So therefore, we can rewrite our question as, for this particular thing, we can directly write down dt, and then this is, we have taken as t only, and this is very simple. We know that integration of 1 upon t is log mod t plus the constant of integration. So it is log mod t is x raised to 10 plus 10 raised to x plus c. And that's your answer. So you have multiple options. So this is the correct choice. Okay, now let's move to the last question of this video. And that is also the last question of this particular exercise 7.2, which is the 39th question. I don't understand the logic here that why they ended at 39. They could have ended at 40th question as well. But anyway, let's do the last question of this video and of this exercise as well. So integration dx sine square x cos square x equals. Okay. So here what are we going to do? We are simply going to substitute here like at the place of 1. You can't see 1, I know that, but we can write down here 1. I can write down this question as this, 1 upon sine square x cos square x dx. Now I can write down this as, we know that this is a very famous trigonometric identity, that is sine square x plus cos square x is 1. So at the place of 1, I can write down sine square x plus cos square x. It's very simple. and then upon sine square x cos square x as it is dx. Now, if I separate the LCM, it will become sine, I'm extremely sorry, here it's sine square x. So this will become sine square x upon sine square x cos square x dx. I'm separating the integration here itself. And then again integration cos square x upon the LCM, that is sine square x cos square x dx. All right, yes, we are almost towards the end. If you are watching the video till here, hats off, because that patience is not in everyone. So very nice. Integration sine square x will get cancelled. So it is 1 upon cos square x dx plus integration cos will get cancelled. So it is 1 upon sine square x dx. Now, whatever answer that you are going to get here, we have a direct formula for that. So cos square x is nothing but sec square x dx plus, we know that 1 upon cos square x is sec square x, right? Now we have integration of 1 upon sine square x. We know that 1 upon sine x is cos x. So 1 upon sine square x will become cos x square x dx. Now we have a direct formula for this. Integration of sec square x is tan x by formula, plus integration of cos x square x is minus cot x by formula, plus c. If you want, I can write down here the formula, that integration of sec square x dx is tan x plus c, the constant of integration, and integration of cos x square x dx is minus cot x plus c. All right, so yeah, and therefore the final answer is tan x plus minus is minus, cot x plus c. This is also a multiple choice question. So if you can see a multiple choices, this is the correct option. And we are done with this exercise as well, and we are done with the video as well. So I hope you have understood all the 39th questions of this particular exercise, that is 7.2 NCERT. And if you have any doubt in any of the questions that I have explained, let me know in the comment section. I'll try to make a short on that particular question, by making you understand once again, and I'll try to simplify it maybe in some other way to make you understand. So yes, thank you so much for watching the video till here. And again, I'll say the same thing. If you are liking my video, if you're liking all the things that I'm making over here, don't forget to subscribe to my channel. Thank you so much for watching.